In this video, we're going to look at how to find the surface area of a square pyramid. So first of all, our formula has changed slightly. Because this is a pyramid, it only has one base. And so that's going to change our total surface area formula. And also notice that for our LSA, instead of the perimeter times the height, it's going to be 1/2 P times L. And this L represents the slant height of the pyramid. So for instance, when I say slant height, I'm going to highlight it real quick so you can see what I'm talking about. And it's going to be here, right? If you went from the center here of the base and then went up to its point, we call that the slant height. So we're going to be having to find the slant height before we can really do anything with this formula. So let's go ahead and start with that. Notice it says first, find the slant height. And so really just look at this like if it's a right triangle. Notice that I did put a right angle sign here, and you'll see that quite frequently in these programs. You're going to see that they note that there's a right angle there, and that actually hits right in the center of that baseline. So what we want to do is consider that it's breaking up this value of 8 into two parts. So really this section from here to here is going to be 4 centimeters, and this section from here to here will also be 4, giving you a total of 8 centimeters for that whole side of the base. And the reason this is important is because we're going to use the Pythagorean theorem, and we're going to use this half, which is 4 units long, and we're going to use the hypotenuse, which is directly across from the right angle, which is given to us at 10.58 centimeters. And we're going to determine what this side of the right triangle is. In other words, this leg, which also happens to be our slant height. So let's substitute our values real quick and go ahead and figure out that slant height so we can start solving this. Now I don't have A, I'm just going to label this. Consider this is side A of a right triangle. Where this 4 is, that's my side B of a right triangle. And this one over here that it's giving me, this is actually my C side of a triangle, the hypotenuse. So we're going to substitute our values. We're looking for A, so I'm simply going to write A squared plus, and for B we have 4, so I'm going to put 4 squared is equal to C, which is 10.58. So 10.58 squared. So now that we got all of our numbers in, let's go ahead and do the math. We want to go ahead and we want to use inverse operations and move 4 squared over to the right side of the equation. Now I know a lot of the teachers will go ahead and square this and then subtract it, but I'm going to let the calculator do the work. So I'm just going to put 4 squared minus 4 squared, which makes it 0. And then I'm going to subtract 4 squared from the right side of the equation as well to keep it balanced. And I'm going to put that in my calculator and let the calculator do all the work. 10.58 squared. And then I'm going to go ahead and I'm going to subtract 4 squared from it. And notice it gives me 95.9364. So I'm going to write that down. So 95.9364. Then I'm going to go ahead and bring down my A squared. And notice we don't want a squared value, we just want A, right? We want a linear measurement. So we do have to unsquare it. And the way we unsquare A is to take the square root of it. And that cancels out the square. So then I'm simply left with A is equal to, and I'm going to take the square root of the number on the right. So I'll just get my calculator back up here. I'm going to hit second x squared to get my radical symbol. I'm going to click up to highlight that value that we had. Hit enter, enter, and it tells me that it is 9.794. Now we're trying to get the height, right? So if I'm looking at this right here, I'm just going to go ahead and round it to the tens place. So I end up with A is equal to 9.8 centimeters. Now this is my slant height. So I'm going to put 9.8 as my slant height over here. And I'm going to add it in and label it real quick. So in this formula, my slant height, that side of the triangle that was represented by A, is actually 9.8 centimeters. So now we have our slant height, right? That cursive looking L. And we have our side values, right? So we have 8. Notice this is a square. So these are the sides. And so I'm going to go ahead and calculate my LSA, or what we call the lateral surface area. So lateral surface area. So let's go and start substituting some numbers in. So this is going to be equal to 1/2 times the perimeter. Now the way we find the perimeter, in case you forgot, you just add up all the sides. And right, notice right, this is a square, so all 4 sides are equal. So this is 8, this is 8, this is 8 over here. This base, right, on the base, that side is 8 as well. So I'm just going to put in there 8 plus 8 plus 8 plus 8. That's going to be my perimeter. And then it's times L. And L is 9.8 centimeters. So 9.8. And once we put this in the calculator, we will have our LSA, our lateral surface area. So let me go ahead. And when I say put this in the calculator, right, I'm talking about these values that we brought down right here. Right, and the 1/2, I brought it down right there. So let me put this in the calculator. And I'm going to go ahead and hit alpha y equals enter to get my fraction bar. Do 1/2 times the perimeter. So parenthesis 8 plus 8 plus 8 plus 8, close parenthesis, times 9.8. And we end up with 156.8. So 156.8 centimeters squared. And that is going to be my lateral surface area. Now we still need to go ahead and get our total surface area. So for that, we're going to use this formula down here, right? So it's really the same. The first part's the same, 1/2 times the perimeter times the slant height, and then plus B. Now normally you would see plus 2B in our area formulas, but I want you to notice that this shape only has one base. And I'm just going to kind of shade it in real quick. This is the base of my shape, right? That square down there, and I'm just shading it in real lightly. And there's only one of them. So if we're talking about surface area, we're just covering one base, and that's why there's just one B. So let's go ahead and substitute our numbers in for the total surface area, TSA. I'm going to write above it, total surface area, and we'll see what that is. Alright, now we already calculated the lateral surface area, and that's represented by this first part of our formula. So instead of me recalculating it, I'm just going to write that answer down here, 156. So I'm going to put it in parentheses. So we have 156.8. Now all I got to do now is go ahead and put in my value for big B, right, which is the area of the base. And if you remember, if we're trying to find the area of a square, we just multiply the length times the width. So big B is just going to be length times width, so it's going to be 8 times 8. So we have 156.8 plus our big B, right, which is 8 times 8. So once we go ahead and multiply these two values together and add it to our lateral surface area, we're going to have our total surface area. So let's go ahead and do that right quick. I'm going to go ahead, type it in, 156.8 plus the area of our base, which is found by multiplying the length times the width, so 8 times 8. And I'm going to hit enter. And I get 220.8. So 220.8 centimeters squared. So now we've answered both questions. Our lateral surface area is 156.8 centimeters squared, and then our total surface area, which includes the base, is 220.8 centimeters squared.